All right, for number 3, it's a triangle problem. And certainly reading it, there's a triangle ABC. The side AB has a length of 6 centimeters. The side BC has a length of 3 centimeters. And AC has a length of 5 centimeters. It goes on to say the angle bisector of angle C bisects the side AB at point D. What is the length of the line segment AD? I have to go to the whiteboard and visualize all that information, by the way. Now, let me see if I can do that. Again, I'm not going to say it's an accurate picture. There's probably enough for me to start figuring this thing out. I keep doing that, don't I? It's number 4. So let's take a look. It's ABC, and the length of AB is 6. So put A here, and I'll put B over here. And that's 6 centimeters. Then they say BC is 3 and AC is 5. So I'm going to try to draw something that looks sort of like that. That's C. Not very accurate, am I? And let me just put this down. This is going to be 3, and this is going to be 5. Make sure I read that right. There's a triangle ABC. AB is 6. I got that. BC is 3. I got that. And AC is 5. I got that. They go on to say there's an angle bisector. So I'm going to say there's a bisector over here. And it meets it at a location there we're going to call D. All right? And I'm going to say this is theta here, and that's theta there. It bisects it. Those angles are equal. And if you thought about it, 2 theta would equal C. And again, I'm not saying it's useful, but that's what that equals. All right? So what I got to do is start thinking about what they're asking about. They want the length of the line segment AD. So they want to know what this segment is over here. All right? So the thing about this one over here is I guess I can write certain things down. And I'm going to try to use the law of sines, because it's certainly going to be easier than using the law of cosines at this point. And I'm going to write this down. So I'm going to say the sine of theta using the law of sines over BD. Put this down over here, is equal to, here comes the tough part. I'm going to select something else. So I'm going to say the sine of the angle BDC. Now, what's the side opposite angle BDC? That would be 3. Okay, I got that. Well, the sine of BDC is exactly the same as the sine of ADC. Again, the sine of angle BDC is the same as the angle of ADC. Got a straight line over there, all right? Over 3. All right. I'm still looking to get AD out of it, though, aren't I? I think I can do it. And I've used law of sines now. I continue to do it. And this would be equal to, I'm looking at this, by the way, ADC would be the same thing as the sine of theta now. I'm looking at this theta. I got the ADC over 3, and that'll be sine theta over the length of AD. All right. Wow. What do I got now? Make sure I said that right, by the way. ADC. No, that's not true. All right, that's not true. The sine of theta over AD is equal to the sine of angle ADC. Again, I'm still looking at this triangle, the left triangle, ADC over 5. Again, I'm still looking at what I got above here. And I'm going to multiply both sides by 5/3 now. So 5/3 times the sine of theta over AD is going to be the sine of angle ADC. These cancel over 3. Well, I know what this is. It's right up here. This is equal to this. Let's write that down. So 5/3 sine theta over AD is equal to sine theta over BD. I got to think. Well, these are going to certainly disappear. And I get 5/3 equals AD over BD. I'm going to go back to my picture though. And I want to point out my picture that 6 is equal to AD plus BD. Just look at that picture over there. I'm glad I had the picture. So let's see if we can put that down. So AD would be 6 minus BD. You know what? I don't want that. Let me get my eraser out. And I'm going to put this down. 5/3. What do I want? I want AD actually. So what's BD equal to? That's going to be 6 minus AD. All right, I think I can do it now. What are you going to get over here? 30 minus 5AD equals 3AD. $30 equals 8AD. And I think I know what AD is now. It's 30 over 8. Let me just reduce that. And that's going to be 15 quarters. If you want, you write that as 3 3/4. Let me see if they give dimensions on this. I have to be careful about this over here. Triangle. Oh yeah, they're centimeters. So what's going to be AD is 3.75 centimeter. If you prefer, you can write down 15 1/4 centimeters, or if you prefer, you can write down 3 3/4 centimeters. And we're done. Thank you.